We're not doing sequence, we're doing function. And then we're gonna talk about how we think about limits of sequences. And we kind of looked at it briefly, the overview, which is basically based on the uppercase N threshold value. And then, okay, so if we have this is the domain now rather than the set of natural numbers. It's the x-axis. If this thing is less than delta and greater than 0, as in right here, our center point, let's call it C actually, that will be better. So we have C, and all the x's that we are thinking about, these are the x's, and they are within delta distance of C. So, or in the interval C minus, should have brought my medicine allergy.
All right.
Yeah.
That comes the year.
Okay, C minus delta, and then you will be served a pizza next week.
That's what you said the last two classes.
I know. Or today.
Yeah.
Not you, Jake. Sorry. Jake, you deserve nothing other than pain of mathematics. Okay. Yeah. Yeah. So if we have this situation, then and then if this is also true, which is f of x, all the values of the function fall near some limit L, and within the distance epsilon. So the epsilon that we use in sequences ends up here. We have to use another Greek alphabet. Then, if a function is going like this, then this is our limit. This is L plus epsilon. This is L minus epsilon. And then these guys better fall in here somewhere. And if they do, then you're all set. Okay, so that's how we do that. This thing here is the definition of a limit of a function. Because and how do we state that? This is the same. This thing in the box is the same as saying limit as x goes to C of a function f of x equals L. This box and this box are the same thing.
Oh.
And okay, and what's going to happen is in 3 to 4 weeks we'll be doing this.
3 to 4 weeks.
Yeah. So the most easiest and natural way to understand limit is to do sequences before functions.
Okay.
Okay, and that's what. So it depends on the book. Some people do function first and then they do sequences. The Belding and Mitchell book, they do sequences first, and I think that's the way to go. Because then you're only dealing with one guy. And you're just dealing with one number line rather than two excesses, and it's all very complicated then. Okay. All right, so I'm going to erase all this. Oh, I shouldn't have. Okay, I'm going to keep that bit over there. Okay, greater than 0. Now we need, how do we express the notion of limit? Here, the notion of limit for the functions is that given an epsilon, find me the interval on the x-axis. I'll give you the interval on the y-axis. Find me the appropriate interval on the x-axis so that the values of the function fall in that given epsilon interval on the y-axis. And then if you make this smaller, because delta's value depends on epsilon's value. We're still doing the function, limit of function. In other words, this interval okay, this will work. This interval depends on the given intervals. This is what we have to find, and this is what is given. Why am I messing up here? Sorry. We're going to have L plus epsilon and L minus epsilon. How come this works? This doesn't work either.
It doesn't?
No. C plus C minus delta and C plus. Because we subtract delta and we get this number on the left. And we subtract, we add delta because it's going to, C is in the middle. C is in the middle. This value is C minus delta. This value is C plus delta. And all the x's fall here. X's.
Yeah, so your epsilon one, that should be reversed. You got it right originally.
The epsilon one is fine too. Oh, yeah, shit.
Did I got you?
Yeah, thank you. Thank you.
Okay.
Yes. Did you get that, Jake? Fix that if you have it wrong.
Yeah, I got it.
Okay, now let's just stop working on this and let's get on the business.
Yeah.
So we have a very complicated relationship of, I'm still on this, so,
I'm sorry, we'll continue. I got
yeah, okay,
I
all
can
right. So
spend
what happens is,
3 hours here. So.
in order to understand the limit phenomenon, and since the other two are not here, we can be here longer. We'll have pizza.
I'm leaving when I see it.
Ah, shit. I'm getting my daughter to order it, and then they'll bring it down here. I'll eat it. Yeah. Okay. Did you hear that, Jake? Why don't you catch a flight and come down?
Just for pizza.
Yeah. Our function has a limit. We are given the interval on the y-axis. That helps us figure out the interval, how big the delta is going to be. We're given epsilon, we figure out the delta, and then we say the limit exists or not if the function values don't fall in that interval of the y-axis.
Say that one more time.
So what happens is we are given an epsilon, a positive number. That epsilon, for instance, could be, let's say, equal to 1. That creates a interval, 1 here and 1 here, right? And here we have L. Now we have an interval on the y-axis. And now what we have to do is take that epsilon and figure out how big the delta is. Okay. And depending on where the function is flowing, if we figure out that this delta is equal to half of that epsilon, and here we'll have the C, the center value, then the x's better hit within the epsilon. And when we do that, it works. Somebody says, no, I'm going to give you an even smaller epsilon. Let's say now the epsilon is half. So then this becomes, I'm just practicing it for when I'll be doing this next in 3 weeks. So then this is half. This better be 1/4, because this needs to shrink so that the function values fall within the interval. And that's how we determine. And what we say is, for if we can show for every epsilon, the function values will fall because we'll always be able to find the delta. For every possible epsilon, we were able to find delta values that restricted the interval here, and still the function values fell within the interval.
Yeah, okay.
Then we have a limit for a function. That's what calculus is about. Now, before I erase this, in sequences, all we have to do is make n large enough. We need to make n large enough. In other words, find the uppercase n large enough so that it hits the a, so that the function values cluster around a. Let me do this better here. So we need to find n large enough so that the terms of the sequence. So now we're thinking about limit. We're thinking about the limit of a sequence SU period minus A. Okay, is less than epsilon. So, so when the terms of the sequence start to cluster. So we need to find the value for n that is big enough, the threshold value for n, then where after that the ANs start to cluster around the limit L. And therefore, n depends on how big epsilon is, on how big epsilon is. If this is very wide, n will get you there quicker. So let's illustrate that before we go on. You are on number line here. This is again all preview of these.
Yeah.
We just did one definition. Okay. But then things will go fast, hopefully. Okay, so we have A1, A2, A3. We have the A here. Let's put it down here because it's another term. Now let's say our epsilon is size 2. This is epsilon plus A, minus. I'll keep messing this up. A, that's good. It's the right color now. Minus epsilon equals 2. And epsilon, A plus epsilon is the limit. Now, AN,
Big N, little n,
big uppercase AN,
that's the threshold, right?
yeah, the threshold can be any number within this range here. So it can be right here. Okay, so n doesn't have to be 244 versus 3 because our epsilon is so big, n doesn't have to be that big. Now if we shrink the epsilon, and now the epsilon is going to be here,
1.
and it's equals 1, then the threshold term with the uppercase n has to be, so the n has to be bigger. So value of n depends on how the smaller the epsilon, the bigger the n. Physics.
Okay.
It's directly proportional.
I got that. Okay.
Yeah, okay. So because we put epsilon as 2, we found the threshold term earlier because n was smaller. if you shrink the, let's say epsilon is now half. This number has to be bigger to get in here. So it's similar to the functional limit of function. Yes, okay, so
I'm gonna be honest with you, I'm not getting that at all.
you're not getting it at all. Okay, very good.
Any event has to be, you said it was like 244, you picked a random number.
Yeah, so now if I make epsilon smaller, this number has to become
Twice
bigger,
as big,
maybe 200, so it went from 2
44,
to 255 maybe,
okay.
and then it will sit right there. All you have to do is move it
But
towards
wait.
the right.
The in, when you say 255 or
It's
240.
just n, value of this, not the real number.
Yeah, no, okay, yeah, so it's the, the term, the level, what,
Yeah, the number of the term.
1 or 2, 1 or 3,
Yeah.
okay.
Yeah,
Oh.
okay,
So I
sorry,
figured
that's,
it out. I
okay.
thought it was the
No,
output of
yeah.
A event, okay.
No. So it's all me, so it's the 244th term.
Okay, yeah.
Thank you for clarifying that, because,
I was like, why are we getting bigger? Yeah, okay.
see, thank you. Nobody protested last time because they were not paying attention at night when it was raining.
Yeah, I just, they're more worried about if we can get.
Okay, Jake, do you understand the problem we had and the solution?
Yeah.
Yeah, okay, very good.
Okay.
So, because it's always fucking confusing because we talk in terms of these numbers. And this is different. This is actually a term. But the n is going to be going from here. The numbers could be anything.
Yeah, okay.
So, in other words, A here is still a big real number, whatever it is. Okay, all right, very good. So let's move on. So therefore, the sentence you want to write is, let's write it here. To kind of solidify our discussion here is the notion of limit. What does it say here? We need to express the notion. This is express the notion of of n being sufficiently large to make the terms of terms an within epsilon of the limit A. So we need, depending on how big the epsilon is, n has to become bigger. If epsilon is very small, then the journey towards the right is going to be longer. So going towards the right, we think in terms of natural numbers, and the sequence themselves, we don't care what the numbers are.
Okay. And just to make sure,
Yes.
touch it, that little n and the big n, they're two different.
This is the variable that takes on different values. Very good. So n takes on. That's a very good question. Actually, this was a question people raised last time too. So this is good. Takes on many values, sorry, all the values from n starting at 1 and then 2 and so on. And n, this n, this upper case n is just one number.
Okay, yeah.
That has to change if the epsilon is very small. So it can at the most will take 3 or 4 values before you find the threshold term.
Wow.
So that this is big enough that it's close enough to the limit. Okay. So that's the layered thinking that goes on in mathematics that throws people off. And that's the job of this class is to make sure we are one with the uppercase n. Okay. All right, let's move on. Very good.